Hello, today we're going to talk about LeetCode question 49, group anagrams. Given an array of strings, group the anagrams together. You can return the answer in any order. So an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So basically, anagram is where all the letters are the same between two words, if they are, but just the order is different. So we have here this list of strings, and we are grouping all the anagrams together. So we have bat, nat, and tan, because they both have tan. They have the exact same letters, just in different order. And ate, eat, and tea. And of course, this guy's empty, so it's empty. So we have an empty string, and we just have one character A, so one character A here. Okay. So the tricky part is figuring out how to determine if all these words are anagrams of each other. We're not just comparing two words, we're comparing one word with multiple other words here. So what we can possibly do is look at a word, focus on a word, and check all other words after it to see if it's an anagram of that. If it is, then we add it to a temp array. For example, if the word in question is eat, then we search for other words. Tea is an anagram of eat, yep, so we add tea, and so on, and then append that to our final result array. But that takes a while. That takes O of n squared. Can we possibly do better? Well, yeah, I think so. So what we can do instead is go through each word only once, so it will not be O of n squared, and take the alphabetical order of the word. So here we have this condition. Each character only consists of lowercase English letters. So what we can do is alphabet or sort them by alphabetically. So with like sort eat, that would be AET. Okay, and we can use a dictionary here to store this anagram. So AET. And the position that this specific anagram is in the result array. So it would be position 0. I'll write that nicer. And obviously our result array would be just consist of E8T. And then we look at the next word, we sort that. We see already in dictionary that EAT, we already found the anagram for EAT, and at position 0 in the result array, we append that word here, so that would be T, and so on and so forth. Time complexity of this would be n times log k, where n is the number of elements in the strings array, and k would be the length of the longest word here. Because it takes n log k to sort, and so it'd actually be n times k log k, because to sort each word, k is representing each character, and n here would be the length of the number of words in the strings array. So this is sorting each word, number of words in the array. but I think we can do better than that. So hitching on the previous idea of using that dictionary, what we can do instead of sorting each word is to actually count the letters in each word. So we can use like an array or a dictionary or to sort of count of each word. I'm going to use an array, and I'll tell you why in a sec. So we have an array of length 26. Initially they would all be 0, where each position represents the lowercase letter of A to Z. So position 0 is A, the number of characters A, position 1 is the number of occurrences of the character B, etc. And we actually iterate through each word and store the number of occurrences we find for each character. So if we have EAT here, eat, we actually have 1 E, so somewhere down the line here we have 1, we have 1 A, so at position 0, we have 1, and somewhere down here we have 1 occurrence of the character T. And we do that, and we store this array into a dictionary. So hitching off the previous idea of storing the sorted word in the dictionary, we store the number of occurrences in the dictionary and the position in the result array where the specific anagram is stored. So we have our result array here, and at position 0 we store all our anagrams for EAT. So EAT. Okay, and if we go on to T, we find that the number of character occurrences array is actually exact same as eat. And since we already have this number of occurrences, this anagram in this dictionary, at position 0 of the result array, we append T, and so on and so forth. So for this, actually in dictionaries we can't store actual arrays or sets or dictionaries as key values, so what we're quickly going to do is convert this array to a tuple as they're immutable. So that would actually be the key here. The time complexity of this would be O of n times k, where n is the length of the strings array, and k would be the length of the longest word, because not only are we going to iterate through the strings array, we're going to also iterate through each word, which is better than O of n times k log k that we had previously with the sorting. So this is what we want here. Okay, now to code this up. So first up, I'll have my result array here. That's what we're going to return at the very end. And we're going to have our anagram dictionary here to store all the anagrams we find. Where remember the key is the tuple of the anagram, and the value would be the position in the results array this anagram is at. So to iterate through the array, what we want to first to do is initialize our character array, where this is going to store the number of occurrences of each character in the word, and they're all going to be 0. And for each character in the word, I'm going to count and store those results in the character array. So character array word char minus word. Okay, so basically what this means is in Python, or it gets the integer value of a Unicode character. I think for A it's like 97 or something, and we subtract that by this character here to zero it out, to make it zero indexed. So if we find the character A, we subtract it by this ordinary word of A, integer value of A, it would wind up being 0. And so for the 0th position, you want to increment by 1. Similarly, if the character, the integer value for the character B would be 98, so 98 minus 97 is 1, so at position 1 represents the number of B's we found in this character array. Okay? And then finally, once we're done iterating through that characters in the word, we want to convert that to a tuple. It's an immutable list in Python because we can't store actual arrays as keys in dictionaries. So I'm just going to convert it to a tuple because tuples can be keys. Okay, if char tuple is in our anagram dictionary here, that means you already found this anagram. So we're just going to append that anagram to the existing anagrams in our result array. So result anagram dictionary char set, remember the value is the position, dot append our word. Else, if we never seen this anagram before, anagram, a dictionary of this char tuple would be when result, because we're going to append this new group in at the end of result, and we're just storing that position there. So finally result.append word. Okay, and finally we can return result. Okay, so remember this is O of n times k, where n is the length of this strings array and k is the length, number of characters in the longest word that we're iterating through. So we create this character array of length 26. We count the number of occurrences of each character in the word we're looking at, stored in this character array, can turn that to a tuple. And if we already found this tuple, meaning we've already found the anagrams like this, then we append this word to the existing set of group of results. Else, we're gonna append this new anagram to the end of the results array. Also while storing the position that we're appending at. Now we're storing at the position we're appending at for all, in case we find this anagram again, then we know which group to append to if we find this anagram again. So start running. Char tuple. Okay. Looks good. Let's try submitting. Okay, great. Thanks for watching.